Hey guys, Mr. Martin with a video over the fundamental theorem of calculus. So we'll just jump straight into examples so you can see what happens when you apply the fundamental theorem of calculus. So in example one, we have to integrate x squared plus 3 from 1 to 2. So when we integrate this, we would get x cubed over 3 plus 3x. So the first change is that when we integrate, we no longer have a plus c because we have these limits. The second change is that we're going to introduce this notation from 1 to 3, which means if we're looking at this, we need to do f of b minus f of a. 3 is our b value and 1 is our a value. So this definite integral is the difference between f of 3 and f of 1. So that would be 3 cubed over 3 plus 3 times 3 minus 1 cubed over 3 plus 3 times 1. So 27 divided by 3 is 9 plus 9 is 18 minus, so 1/3 plus 3 is 10 thirds. So 18 minus 10 thirds is 44 thirds. So let me grab a calculator. Sorry about that. So let's see what happened. Wrong calculator. All right, terrible. All right. So let's graph this function x squared plus 3. And our limits were from 1 to 2, so from 4 to 7. So let's set our window so we can see what's happening. 4 to 7. Let's go 0 to 7. And actually, let's change the limits from 0 to 3. So when we do a definite integral, what we're finding is the area between the curve and, generally speaking, the x-axis. So from 1 to 2 would be us finding the area of this region. And that value turns out to be 44 thirds. So we don't need a graph to understand how to do this. It's just helpful in illustrating the concept. So for example 2, the first thing we should do is rewrite this so that it is, right, so x divided by x to the 1/2 is x to the 1/2, and 4 over x to the 1/2 is minus 4x to the negative 1/2. And so when we integrate, we will get 2/3 x to the 3/2 minus, so we're going to have 4x to the positive 1/2 divided by 1/2. So minus 8x to the positive 1/2. And we're evaluating from 1 to 9. So this would be 2/3 times 9 to the 3/2 minus 8 times 9 to the 1/2 minus, so for 1, it's just going to be 2/3 minus 8. The square root of 9 is 3 cubed is 27, divided by 3 is 9, times 2 is 18. The square root of 9 is 3 times negative 8 is, so minus 24. So this reduces to be negative 6. So we have negative 6 minus 8 is the same as 24 thirds. So 2 thirds minus 24 thirds is minus negative 22 thirds, which negative 6 is negative 18 thirds. So negative 18 thirds plus 22 thirds gives us a result of 4 thirds. I do want to show you that on your calculator, you should be able to check this. Let's see how we do this. You go to math, number, where is it? Math, oh, it's integrate. So, we'll do function integrate, and our limits are 1 to 9, and our function is x minus 4 divided by the square root of x, and we'll put a dx. And so we get the answer that we did by hand, which is 4 thirds. So it's a handy way of checking your work in case you're not confident that you did it correctly. Example 3. So integrating secant squared x. Whose derivative is secant squared? That would be tangent x, and we evaluate it from 0 to pi over 4. So that is the tangent of pi over 4 minus the tangent of 0, which equals 1 minus 0, which is 1. For the fourth example, we have the absolute value of 2x minus 1 dx. And for absolute value integrals, you need to check if the function, the vertex for the absolute value function is inside the interval. If we did a quick check on this, 2x minus 1 equals 0, we end up with x equals a half. So the absolute value of 2x minus 1 is going to equal 2x minus 1 if x is greater than or equal to a half. It's going to be negative 2x minus 1 if x is less than a half. So all that means is that this integral produces two different integrals. So we split this limit to be, what do we have on? We'll say the integral from 0 to 1/2 when it's, so from 0 to a half, we're going to have negative 2x minus 1, which is negative 2x plus 1 dx. And then we're going to have a separate integral that is from 1/2 to 3 of 2x minus 1 dx. So all that happens is the signs for the terms flip. When we integrate, we will get negative x squared plus x evaluated from 0 to a half for the first integral. When we substitute in a half, we will get negative 1/4 plus a half minus, when we substitute in 0, we will have 0, we'll have 0 plus 0. So negative 1/4 plus a half is just 1/4. So this first integral gave us a result of 1/4. The second integral, we should get the same terms. We should still get x squared. We should still get x evaluated from a half to 3. So when we substitute in a half, again, we should get the same thing, but maybe the signs flip. Here we got 1/4. Here we expect to get negative 1/4. We would have 1/4 minus a half minus, when we substitute in 3, we have 9 minus 3. So that's negative 1/4 minus, I did this backwards. Take that back. 3 is the upper limit, so we should have 9 minus 6 minus 1/4 minus a half. So that's going to be 3 minus negative 1/4, which 3 is 12/4 plus a fourth. So it's going to be 13/4 plus 1/4. So 1/4 plus 13/4 is 14/4 or 7/2. If we graph this function, it would be the vertex is a half right here, and the slope is, let's see, we have 1, 2, 3, 4. So from here we go up to and over 1, and up 2 and over 1, and I guess at 3 up 2 and over 1 will look something like this. So really, it's the area of two triangles. The area of this first rectangle is 1/2 base times height. The area of the second triangle is also 1/2 base times height. If you just did geometry, you get the same answer. Example 5. This will be the last example we do in this video. We'll make a separate video about area between two curves. So example 5. We have the absolute value of x squared minus 4. So for quadratic inequalities, we need to determine where the inequality is, we'll say, greater than or equal to 0. Now, this is a difference of perfect squares. X minus 2 times x plus 2 is greater than or equal to 0. So x equals 2, x equals negative 2. Very similar to the first derivative test, we put our critical values, so negative 2 and positive 2 on the number line, and say we choose x equals 0, that's clearly going to produce a negative 4, and it should just alternate signs because these roots are of odd multiplicity. The way this function looks is, we'll draw two graphs. So x squared minus 4 is basically a parabola that has been shifted down 4 units. So then we expect 1, 3, and negative 1, 3, and 2, 0, and negative 2, 0 to be points on this graph. So what the absolute value does is it takes this function and it takes the negative values and flips them over the x-axis. So the part that is above the x-axis is going to stay intact, but this other part is going to flip and do something like this. So we need to determine where the purple graph is negative and flip our integral accordingly. So we know that it's negative from negative 2 to positive 2. Our limits are from negative 1 to 3. So that means that we're going to rewrite this to equal two different integrals. So from negative 1 to positive 2, we need to do the opposite of this function. So that's just going to be 4 minus x squared dx, so that from -1 to 2, everything is positive, and then plus the integral from 2 to 3 of just x squared minus 4 dx. So the integrating should be simple. We will get 4x minus x cubed over 3, evaluated from -1 to 2, plus the other integral, x cubed over 3 minus 4x, evaluated from 2 to 3. So let's just take the shortcut here so we don't have to do the work by hand. Math 9. So we have two different integrals. One is from -1 to 2, 4x minus x cubed. What am I saying? This should be -1 to 2 of 4 minus x squared dx. We get 9. So -1 to 2. Yeah. So this integral equals 9, and math 9, so 2 to 3 of x squared minus 4 dx, 2.33, what's that, 7/3. So 7/3. So the total area is 27/3 plus 7/3, which is 34/3. So that concludes this video on definite integrals. The second video will cover these two examples.